All right, so here's a little exercise in idealistic thinking. Let me start off by giving you a trick question. I'll give you that warning. It's a trick question. We'll see how much of an idealist you are right off the bat. Here we go. Okay. The question is, what is that? Got your answer? Okay. Did you say triangle? If so, wrong. That's not a triangle. Not from the idealist way of thinking about it. It might look like a triangle. You might have been conditioned by your upbringing and your current state of cognitive development to think of this as a triangle, but this is not a triangle. Why not? All right, well, what is a triangle? Right, we are philosopher, mathematicians of an idealistic sort. What is a triangle? Let's wrap our minds around first clearly the concept of being a triangle. So for that, I will put on the board, there's our word, triangle, and we want to get very clear and see if we can come up with a definition of what a triangle is. Okay, and I will offer this definition. We can quibble over it if necessary, but I think it's a pretty good one. We would say something like the following: a triangle is an enclosed, three-sided figure with interior angles that add up to 180 degrees. Fair enough? And that captures, I think, the central insight that most of us have about what a triangle is. An enclosed three-sided figure with interior angles that add up to 180 degrees. Okay, so what we now have then is an abstract general formulation that hopefully will fit all of the triangles, right, that are true of the world. Now we take this abstract formulation and then we look at this particular thing over here that I've drawn on the board and we say, well, does this fit the definition? If it fits the definition, then certainly it's a triangle, but if it doesn't fit the definition, then it can't be a triangle. And so the first thing we would have to say is, well, first thing is this word enclosed, right? It has to be an enclosed, right, three-sided figure. And this is where I was a little bit sneaky, why I said this was a trick question. In fact, as it happens, this is not enclosed. If you look closely here, there's a bit of a gap. Right? Aha, that's not just philosophy trickery, right? That's an important truth. In many cases, in the lower natural world, when we're talking about triangles, right, we'll use the term more loosely. In this case, it's not actually an enclosed, it's pretty close to being enclosed, but it's not in fact enclosed, so it doesn't meet the definition here. We might say that the three sides in a triangle are supposed to be straight lines. I might have incorporated that into the definition, in which case certainly this line over here is suspect, and this bottom line, well, that's just horrible, whoever drew that. That's not even straight at all, so that's not really a triangle at all. What about the latter part of the phrase here, interior angles that add up to 180 degrees? I would bet a great deal of money if we were to take a protractor, put it on the board, measure these three angles here, add them up. It wouldn't come out to 180 degrees. It might come out to 178 degrees, 184 degrees, who knows, but it's not going to be 180 degrees. Even if I had a crude protractor and it came out to 180 degrees, I could come back and say, well, with a more precise protractor, there are going to be minor differences or minor offset angles here that are not going to allow it to add up to 180 degrees. So what we then have to say as idealists is, this isn't really a triangle. We might say that it's a kind of, sort of, in the area, so to speak, triangle. But it's not really a triangle. A triangle is only that which meets this definition. And then, of course, we can ask the follow-up question, if this is not a triangle, and if we had really fine-grained protractors and measured all the triangles that exist in the world, are there any triangles in the world? And the strict idealist is going to say, no, there are no triangles in the world. What we have in the world are things that are corrupt, things that are constantly in a process of change, right? This is expanding and contracting as the temperatures change in a very slight direction here. The only place where we find actual triangles, that is to say things that meet this definition, are going to be in a higher world, right? And the reason why the Pythagorean theorem is true now, just as it was true 2,500 years ago, and will be true 2,500 years from now, is that the triangularity, that abstract, completely general, straight, exists in a higher realm of eternal perfect essences, right, and so to speak. And by contrast, if I take my eraser, this triangle here did exist, or whatever it was, I mistakenly called it a triangle, doesn't exist anymore. It's subject to a process of change and corruption. It comes into existence and comes out of existence, but triangularity never changes, right? What it is to be a triangle is eternal and it is perfect. All right, that's an exercise in thinking metaphysically and epistemologically rather as an idealist.